variety, emerald is so attractive and so desirable to own that the successful synthesis of this variety was of more than just scientific interest. Even the modest success of extreme on the recrystallization of rubies from fragments of natural stones was quite encouraging for researchers who carried out similar experiments with crushed burplets. The color, which changed when heated in a flame of detonating gas, was restored by the preliminary addition of a small amount of chromium oxide. However, these experiments failed. During melting, each time the glass fell out, not the crystal. Consequently, it was a sad mistake to call such products scientific emeralds, because since they were neither emeralds nor even scientific ones. They differed from true emeralds, firstly in color. Although green, but the color of leaves and not a real emerald. And in artificial stones, optical effects are almost always observed. Synthetic stones. Secondly, according to physical properties, refractive index 1.5 and a specific gravity 2.4, which were slightly lower than those of emerald crystals. The production of beryl glass by melting beryl fragments in a flame of detonating gas is not an innovation. Indeed, it has been known since the beginning of the last century, but did not attract the attention of jewelers until the moment when the possibility of obtaining synthetic stones was established. The first successful experiments in the synthesis of emeralds, apparently carried out by Hotfel and Piret. During long and complex experiments on the preparation of various beryllium silicates, they managed to obtain tiny crystals of emeralds. They achieved the best results by placing a mixture of beryllium, silica, and alumina in proportions corresponding to the composition of beryl and the lithium demolybdate coating in a platinum crucible, which placed in an autoclave. Temperature, after being raised to a gentle heat and maintained at the level for 24 hours, was raised to nearly 800 degrees Celsius and held at this point for 15 days. It turned out that the temperature should not exceed 800 Celsius, since otherwise beryllium silicate pentoxide will be formed instead of beryl. At the first stage, the lithium compound gave crystals in the form of octahedra. Then, as the temperature increased, the octahedra were replaced by prismatic beryl crystals. And finally, when all the octahedra disappeared, larger prism, as a rule, grew at the expense of small ones. At the end of the experiment, after cooling, the mass was crushed by dissolving it in dilute hydrochloric acid. Beryl crystals were released. It was found that the crystals, free of inclusions as far as possible, have a specific gravity of 2.67, and their composition exactly corresponds to the beryl formula. At a temperature of 750 Celsius, the crystals were obtained in the form of a short tabular hexagonal prism, and at 800 Celsius they became more elongated, so that the length was equal to either the diameter or exceeded it approximately 1.5 times. The addition of chromium to the mixture gave the crystals have a green tint, as bright as the best natural emeralds. If the additive was 0.001 of the mixture, the oxide chromium was completely absorbed by the crystals. And if it reached 0.003, then most of the chromium oxide remained in the host mass. The crystals were almost perfect in shape, although too small for jewelry purposes. In 1911, the Farbwerke industry company in Bitterfeld began experiments that began with repeating the experiments of Hautfeld and Perret. The first individual crystals of synthetic emeralds suitable for cutting were obtained almost 20 years later. They were marked under the brand name Emerald. No detailed reports about this were published at that time, but in 1942 the production of stones stopped, and then a description of the process appeared. The crystals were grown from a melt of beryllium oxide, aluminum oxide, silica O2, adding lithium acid molybdate as a flux in a platinum crucible, which was heated using electricity. It turned out that the necessarily condition is the absence of supersaturation of the mixture, which occurred when all three components were distributed evenly, as a result of which only small crystals were formed. Therefore, silica was supplied in the form of crushed quartz placed on a platinum grid at a short distance from the bottom of the vessel. Reproducing the formation of emerald color encountered some difficulties. The addition of chromium O gave a bluish-green tint, but in the end it was possible to obtain a druce of crystals with the same excellent color as the best natural emeralds, and large enough to, after cutting, give stones weighing at least 1 carat. Emerald clearly showed brighter fluorescence in ultraviolet light than natural emeralds. In addition, the refractive index by fragments and specific gravity of synthetic emeralds have been found to be below the lowest values observed for natural emeralds. Almost simultaneously with the experiments carried out by Farbwerke industry, Carroll Chatham began experiments in scientific research laboratory near San Francisco. He grew the first artificial emerald weighing 1 carat in 1935, and from 1940 the reproduction of industrial products was established. A rough crystal weighing almost 1,000 carat was donated to the Smithsonian Institution for its gem collection, and another weighing 1,300 carats.